So now let us go to our next topic, Venn diagrams. So we have seen the three topics D, R and T. Definition, representation and terminology. We have done that. Now we have come to the next segment, fall in love. So this statement have to be read from reverse. So V comes first, then comes operations, then come laws, lastly you get formulas. So let us first see the concept of Venn diagram. So Venn diagrams are a way in which we can represent sets pictorially. So represent sets pictorially. So Venn is the name of a mathematician. Euler and Venn combinedly gave these diagrams. So what do we do in Venn diagrams? So in Venn diagrams you have only two rules. So in Venn diagrams, universal set is represented by a rectangle. Universal set is represented by a rectangle. And individual sets in the problem are represented by circles or ovals. Circles or ovals. So you need to remember these two. Universal set is a rectangle. Individual sets are circles or ovals. And if there are common elements in two sets, they are represented by intersecting circles. And what is the opposite of this? If there are no common elements implies non-intersecting circles. No common elements implies non-intersecting circles. For example, let us take two sets. A is the set containing 1, 2, 3, 4 and 5. And let us take a set B which is 3, 6, 8, 4, 9. Let's take these two sets. Now, let us represent these two sets using a Venn diagram. So what do I do? First, I take a universal set. So universal set, as we have seen, can be any set which contains all the sets under consideration. So in this question, we are considering only two sets. So universal set is a set which is bigger than the combined of this. It has to be a superset for this as well as this. That means all the elements present in A and B are present in this. So this is the universal set. I'll represent it by U. This is the universal set. Now, individual sets are represented by circles or ovals. So I'll represent this by circle. Okay. So that means these elements 1, 2, 3, 4, 5 are present in this circle. Now, if there are any common elements in two sets, they are represented by intersecting circles. So let us see whether there are any common elements or not. 3 and 4 are common if you see. So they are common. So I'll represent them using intersecting circles. So this is my set B. Now I'll fill the elements of these sets in this diagram. So as you can see, Venn diagram has to be always filled inside out. So this is something which you need to remember. So in the topic of Venn diagram, you have the code word inside out. Inside out. Inside out. So you have to start filling the Venn diagram from inside. Then you have to go outside. So what is the innermost part? Innermost part is the common part of A and B. So what are the elements common in A and B? 3 and 4, right? So 3 and 4 has to be filled in the common part. So this 3 and 4 belongs to this circle as well as this circle. That means they are present in set A as well as B. Next, we fill the other elements. So 1, 2, 5. 1, 2, 5 are elements which are present only in A, not in B. And what are the elements present in only B, not in A? 6, 8, 9. 6, 8, 9. And for example, if you take the universal set as set containing 1, 2, 3, so on up to 10, yes, this can be taken as a universal set because this contains all the elements of B as well as all the elements of A. It can contain more elements also. So once you have filled all the elements, 1, 2, 3, 4, 5 is filled, 6, 8, 9 are filled, and the universal set, that means this rectangle contains all these elements. So these elements are filled already. What are the elements which are left out? As you can see, 7 is left out and 10 is left out. So 7 and 10 lies outside these two sets in the universal set. The space outside is belonging to those elements of universal set which are not present in A and B. So I hope you have understood this concept of Venn diagram. So let us look at two more examples. So next, let us look at this example. A is the set 1, 2 and 3 and B is the set containing 1, 2, 3 and 4. So this is a special case. As you can see here, A is a subset of B. Because all the elements in A are also present in B. And the universal set is 1, 2, 3 and 4 and 5. So whenever A is a subset of B, how do we represent it in Venn diagrams? So if you draw the Venn diagram, so let me tell you two cases. So if I generally use the concept that we have learned, A is a circle and B is a circle, and you have a universal set here, right? So how do I fill the elements? Inside out. So if this is A and this is B, so first, what are the common elements in A and B? 1, 2, 3, all these come in the intersection. And there are no elements in A which are not present in B. And what comes in this interval? We have 4 here. 1, 2, 3, 4 are present in B. 1, 2, 3 are present in A. And the universal set is 1, 2, 3, 4, 5. That means 5 is present outside the interval. So we have a total of 1, 2, 3, 4, 5 elements in the universal set. So this is one way to represent. There is nothing wrong about it. But so whenever you have subsets, we have a better way to represent them. So whenever one set is a subset of another, what you do is you draw the universal set and you have the set A, and you'll draw a set B enclosing A. So this outer circle is set B, the inner circle is set A. So now what you do is you fill elements now. So in the set A you have 1, 2, 3. Obviously this set is contained within set B. That means A is a subset of B. It's very clear from this diagram that A is inside set B, that is A is a subset of B. So whenever you have one set subset of other, you draw that set completely inside the second set. And next you have an element 4 which is present in B but not in A. This 4 is outside A but inside B. And the universal set is the total rectangle. As you can see, universal set is encompassing all this. So 1, 2, 3, 4 have already been covered. So you have an extra 5 in the universal set. 5 is present in the universal set but not in B. 4 is present in B but not in A. This 1, 2, 3, 4 are present both in A and B. So what have you learned in this question? So whenever a set is a subset of another set, we draw that set completely inside the other set. You can also draw it like this, but here it's not very clear that A is a subset of B. Okay. Next, let us go to this question where you have 3 sets. Instead of 2 sets, you have 3 sets. A is 1, 2, 3, 4, B is 2, 5, 6, 8, C is 1, 2, 5, 9, and universal set is 1 to 10. So how do we draw the Venn diagram for this? First, let us draw the universal set. Next, let us draw circles corresponding to the sets. So let this be the set A. Now let this be set B. There are some intersection. So I'll draw an intersection. Let this be the set B. Now as you can see, set C might have intersection with A as well as B. So if I draw set C here, you cannot show the intersection with A. So what we usually do is we draw C like this, below this, so that each and every circle has intersection with the other circles. We draw 3 intersecting circles whenever you have 3 sets. Let this be A, let this be B, let this be the set C. So now let us fill the elements in these sets. So remember the code word, inside out. Say it loudly, inside out. So first, what is the innermost part? This is the innermost part. This is the part which belongs to A as well as B as well as C. So is there any element which is present in all the 3 sets? So as you can see, 2 is present here, 2 is present in B, 2 is also present in C. That means 2 is present in the common region of ABC. So here you write 2. That is the place for 2. That's a common place for all the sets. Next, these 3 are the next innermost things. So once you fill this, you go for these 3. So first, what are the elements present in both A and B? So if you see A and B, 2 is the common element, 1 is not there, 3 is not a common element, 4 is not a common element. So only 2 is a common element of A and B. So there are no elements here. There are no elements here. Next, if you go for this, this is the common part of A and C. Already 2 has been obtained in this. Already 2 has been obtained in this. There are no elements here. So already 2 has been obtained. So let us look at B and C. You have 2. You also have a 5 which is common. Sorry, this is for B and C. For B and C, apart from 2, you have a 5 common. So 2 has already been written. 5. 5 is present in B and C but not in A. Next, let us go for A and C. So if you go for A and C, 1 is there, 2 is there. So both 1 and 2 are common. So 2 has already been written. So 1 will be written here. So 1 is common to A and C but not present in B. So once you fill all the 3 spaces, next you go for the bigger spaces. So now, what are the elements present in set A? 1 and 2 has already been considered. They are inside the circle. So the remaining elements are 3 and 4. Go for B. 2 and 5 are already considered. You write 6 and 8 here. You go for C. 1, 2 and 5 have already been considered. 1, 2, 5 are inside C. What is the element left? 9. So I have filled the elements in ABC. Now we know that the outer rectangle is a universal set. So are there any elements in the universal set which are not present in ABC? 1, 2, 3, 4, 5, 6, 7 is missing, 8, 9, 10 is missing. So this 7 and 10 lies outside ABC but inside the universal set. So now once you fill this Venn diagram, you can answer certain questions very easily. So if I ask you, what are the elements present in A but not in B and C? That is, what are the elements present only in A but not in B and C? So what are the elements present only in A but not in B and C? So the answer would be 3 and 4. So 3 and 4 are the elements which are present only in A but not in others. So if I darken this, this is the area corresponding to the elements which are present only in A but not in others. So this is the area corresponding to the elements which are present only in C but not in others. So if I ask you to find elements only in B but not in others, you have to see the elements in this area, 6 and 8. Now what are the elements present in both A and C but not in B? Both A and C but not in B is this area. Belongs to both A and C but not in B. This area corresponds to the area the elements present in both B and C but not in A. This region corresponds to the area. This region corresponds to the elements which are present in A and B but not in C. So there are no elements which are present in A and B but not in C. Next, this is the area which is corresponding to all the sets A, B, C. So whatever elements come here, they belong to all the sets. And what are the elements outside this? So the outside region corresponds to those elements which are neither present in A, nor present in B, nor present in C. So I hope you have understood this topic. Let's go forward.